Now, let us move on to the second part of the panel, which will discuss the future of rain enhancement, roadmap, department, and challenges. Please welcome our panelists, Dr. Dion Turbalanch, Dr. Estelle D. Conning, and Professor Stephen Sims, and Mr. Omar El Yazidi. Moderating this session will be Dr. Robert Robinson.
Hello, everyone. We're start this part of the road mapping session. And just as a few remarks about road mapping, because of the complexity of rain enhancement sciences and all the global efforts that are being expended by different governments in academia, in industry.
Start this part of the road mapping.
It's important to develop both a vision for where we'd like to be in the future,
a few remarks about
and a roadmap
because of the complexity
on how we're going to achieve that vision.
Sciences and all
so
the
a roadmap
efforts
looks at what's been done, what are the gaps,
by different governments in academia,
what's the path forward,
in industry,
and what are the milestones along the way.
So it's important to develop.
So much has been done toward developing this roadmap already, and our distinguished panel today will provide insights about some of the progress that's been made.
So a roadmap.
So we'll start with questions for Dr. DeConing. In your role as acting head of the World Weather Research Program, can you tell us about global scale?
Good afternoon. Thank you very much for the honor to be part of this 5th International Rain Enhancement Forum. I'm really honored to be in this panel, and I thank you for inviting me. If we think about the global scale initiatives, I can start with the WMO mission statement. In this mission statement, we say that the WMO works to facilitate worldwide cooperation, and we want to foster the exchange of meteorological information, and we want to advance the standardization of these meteorological data. But most importantly, we want to build cooperation between meteorological, hydrological services, as well as academia and partners from the private sectors, to encourage research and training in meteorology. And we want to expand the use of meteorology to benefit other sectors, such as aviation or shipping or agriculture, and most importantly, water management. In the WMO strategic plan that is currently available until 2023, we have 5 long-term and strategic objectives. We want to make data more accessible. We want to have better services to our members, and in the same process, close the capacity gap, of course. But the most important for our conversation today is goal 3. We want to advance targeted research, leveraging the leadership in science to improve the understanding of the Earth system for enhanced services. This is really, really important, and this is where the research work that happens in the World Weather Research Program fits in. The WWRP implementation plan, also valid until 2023, has 4 scientific or societal challenges. And one of these is the water cycle. And that includes all the work on precipitation and cloud microphysics that also is the topic of today's discussion. The WWRP has an expert team consisting of various experts from all over the world to collaborate to improve the knowledge of weather modification work. And this expertise is then applied to promote scientific practices in weather modification research. And Stephen Sims, also on the panel, is the co-chair of this group. Thank you.
Thank you. Yes, certainly the ability to leverage all of the different activities, particularly in the research, is very important. So maybe I'll ask a question to Professor Sims. Can you share with us your insights on the way forward for rain enhancement, particularly on the role international collaborations can play? Can you give examples on research collaborations you've been involved with?
Yes, I too would like to thank you for the invitation to speak today. It's really great to participate in this event once again. It's always quite enjoyable. Look, I think the way forward for cloud seeding, for rainfall enhancement, is in many ways as it has been. It's quality research. Quality research underpins all of our advances that we make here. And in the previous session, I remember hearing Dion mention that we can't have shortcuts. We can't miss steps along the way. And I think, you know, over the last 20 years, we have seen some tremendous progress in the field. Progress in field experiments with detailed observations, new instrumentation that we haven't been able to use before. We've been able to utilize this to gain new insight, lab experiments, cloud chambers that are advancing, and numerical simulations. I mean, we are all aware of how much numerical simulations have advanced. And in the future, these are going to continue. I mean, we are seeing rapid changes, and I think this is going to really, you know, help bring a lot more credibility to the field, a lot more success to the field, a lot more visibility to the field, as we've seen. The international collaboration, well, it's essential. I mean, not only for the credibility, but also for the synergy, for the energy. I mean, we can bring in experts in cloud drone or in drones. We can bring in experts in artificial intelligence. I mean, the UAE program has been tremendously successful on this. Experts in cloud microphysics, experts in field observations. These are going to help us. These are going to help drive our way forward. Bringing in these outside, or these I don't know what's the right word here. These experts from diverse fields to help us advance the field, advance cloud seeding. As for myself, well, I probably, with regards to cloud seeding, I was involved in a Queensland cloud seeding project about 10, 12 years ago for hygroscopic seeding when there was a drought in southeast Queensland in the Brisbane area. There were scientists from the United States, scientists from South Africa. It was a very, very good international collaboration. More recently, I'm involved in a marine cloud brightening project, or I'm involved in some of the oversight of a marine cloud brightening project over the Great Barrier Reef. Outside of cloud seeding, I also study clouds and precipitation over the Southern Ocean, and there's been quite a bit of activity over that in the past few years. So thank you.
Thank you. Yeah, I totally agree that the UAE REP has been both a benefit in terms of catalyzing all the work that's being done, but also bringing together the experts from all over the world. Sort of continuing on the theme of international collaboration, Mr. Al-Yazidi, can you tell us about current and possible future international collaborations that NCM has with other countries or international entities, you know, along the lines of advancing rain enhancement?
Yes, thank you, Dr. Robert. And I would like to take this opportunity to thank you all for participating in this such important event. And talking about the collaboration and international collaboration, which is an essential part of this initiative. To tell you about the current collaborations, for example, the National Center of Meteorology is a member of the World Meteorological Organization and its Executive Council, the Intergovernmental Coordination Group for Indian Ocean, to tsunami warnings and mitigation system. Also, the Tropical Cyclone Committee for the Indian Ocean. The executive, he's also a member of the Executive Office of the Council of Arab Ministers for Meteorology and Climate Affairs. In addition to that, it's also the Permanent Arab Meteorological Organization, and the also currently heading the Regional Association 2, RA2, Asia, on the World Meteorological Organization. So the NCM actually, and through this program, the UAE Research Program for Rain Enhancement Science, through National Center of Meteorology, has established collaborations with many entities from all over the world. So, for example, from China, we worked with Japan, with Russia, with Germany, also collaborations with Finland, and also both the United Kingdom and the United States of America. So we work on different aspects that deepening the knowledge of the field in rain enhancement and weather modification in general. This is again part of the driving international efforts to advance the meteorological science and advancing rainfall enhancements through these collaboration. So NCM is actually working through this initiative to fulfill the United Arab Emirates innovation strategy quest to build the leading global knowledge economy in accordance with Abu Dhabi 2030 vision. Yeah, thank you.
Thank you. Thank you. It's very true that the NCM leadership in this program has been outstanding, and we've seen so much progress made in the past few years because of that leadership. Dr. Terblanche, Dion, so switching to a little bit about the science gaps, as an expert in weather modification, so what key gaps do you think need to be addressed in science and technology to overcome both the current and future challenges in rain enhancement?
Well, thank you very much, Bob. I think it's all about cause and effect and having a clear idea of those two issues. Cause and effect. If you apply a certain seeding material to a cloud, you must be able in a stepwise way to follow the full process until rain reaches the ground or it doesn't reach the ground. So it's actually a forecasting problem. Rainfall enhancement is basically a forecasting problem. If we had ideal models, we would have been able to run simulations of seeded and non-seeded clouds and get an answer that is quite believable and true. But we are not there yet. So this indicates that we need to do quite considerable more work on model development. And model development implies also to get the microphysics right. This is an issue of scale, and it's a very complex issue. And so when you run global models, it's very difficult also to simulate at the same time things that happen at the micrometer scale. And so with improved artificial intelligence, computing systems, big data, we will eventually get there, because I believe that models will eventually be the solution to finding out how efficient cloud seeding material would be when applied in nature, so that we don't have to go through all these rather elaborate randomized seeding experiments where there's little appetite to conduct experiments that takes many, many years before you have an idea of what's really going on. So in my mind, the modeling issue is really important, and all the tools that we now have in terms of artificial intelligence and data mining and new instrumentation to try and get closer to reality. But in that process, we need skilled people. And the UAE program has been producing a new generation of people and interest in this field, which has been sorely lacking in the last couple of decades. So skilled people with a keen interest and an inquiring mind is really important to this field. People that are with a tenacity that won't give up. And then I think the issue of using the best instrumentation available these days in terms of radar, advanced aircraft instrumentation, but also other remote sensing techniques is really important. And then eventually is this thing of having open data policies, sharing information, thinking very carefully before you patent something that should actually be in the public good domain so that all the scientists can work further and refine it and make it something that is worthwhile for humanity. So international cooperation and how people manage and share data in a discoverable manner, I think is really important in this field. So I'll stop there, Bob.
Yeah, thanks, Dion. I think you've touched on many of the elements that are making this program successful. And, you know, we have this very diverse array of 9 awardees so far, but we've found that all of them hinge on understanding the basic science, the microphysics that underpins everything. So thanks for those comments. So we mentioned part of the roadmap is understanding where we are now and where we have to go. Part of where we are now has been captured in a recent WMO report. So why don't we talk about that for a little bit? Dr. de Koning, the WMO Congress approved a statement on practices for rain enhancement in 2018. Could you elaborate more on this and the role it plays in addressing the field's challenges?
Yes, certainly. In 2018, this guidance document was approved by Congress, or Council, as you mentioned, and there were 3 main statements. The first statement said weather modification should progress the strategic research to investigate and test the scientific hypotheses on which weather modification is based. And this includes a wide range of applications such as water management and climate change adaptation, as we heard in some of the previous speakers earlier today. It should also demonstrate scientific and economic feasibility, of course, and validation should be a prerequisite before something is made operational. The second statement says that we should take into account all the considerable uncertainties in this field and the challenges related to the validation of such activities. And the third, which touches on the statement Dion just made, is that there should be a data management plan that ensures that the data are available for future analyses, that the members should share their experiences and expertise in weather modification to avoid duplication and to enhance international collaboration. So these are excellent guiding principles that we have referred to many people who have inquired about this field. And thus we play a vital role in addressing the field's challenges in a systematic
way. Thank you. So Professor Siems, what research and development programs do you envision being needed to fill these key gaps in science and technology related to rain enhancement?
Well, I think referring back to some of Dion's comments that, you know, using artificial intelligence, using machine learning to try to get a better handle on this microphysics is going to be essential moving forward. This will help improve the models. But machine learning, artificial intelligence are data-hungry processes. It requires very good observations and very large quantities of observations. We know that. And so I think what we really will be seeing happening is some very, very rigorous observational programs, trying to get us these interactions, trying to show us, you know, record what happens when we inject these aerosols into these clouds. And then we can use some of these advanced techniques to improve our models. I mean, I completely agree with Dion that our models, our understanding of microphysics at present are not sufficient to help us evaluate rainfall enhancement programs. We know just on an unseeded cloud, if we use the same model, same thermodynamic setup, same environment, but we change the microphysics schemes, we can get different clouds, different precipitation amounts. So we need some considerable advancement in refining the microphysics before we can go forward too far. Thank you.
Very good. Very good. Dr. de Koning, going back to the WMO report of 2018, can you tell us about what you think is the importance of this report and maybe some of the background of why it was commissioned?
In 2017, there was a survey done amongst WMO members involved in weather modification to see what they're busy with and what the needs are. And this showed that precipitation enhancement activities are carried out primarily in response to water shortages, affecting agriculture and, of course, social needs. Cloud seeding is done in numerous countries around the world. We've learned about that earlier this morning as well, or earlier today. And it is really important to undertake such activities in a rigorous analysis methodology, that we don't just do it in a haphazard way. So the expert team on weather modification is tasked to regularly update our WMO statement and our guidelines for such practices. But in order to do something a little bit more global, the UAE kindly supported an initiative that this expert team should put together a peer-reviewed assessment of all the rainfall enhancement activities around the world. And this group worked together very well under the leadership of Professor Andrea Flossman, and an extensive report was compiled with financial support from the UAE. And this report was also published in the Bulletin of American Met Society in a shortened fashion. And the WMO is extremely grateful to the support that the UAE is giving to this initiative in the past, but also for all the projects that are currently underway and also the next phase that has been launched today to support ongoing funded projects on this topic.
Thank you. And so Dion, as former director of research at the WMO, can you tell us something about the main outcomes and recommendations of the report? It was a big report and it had a lot of content, but maybe you can give us some of the key takeaways from that.
There were basically 5 issues or 5 headings with recommendations. The first one dealt with fundamentals, understanding the fundamentals. In terms of that, the expert team said that we need more information on the formation and growth of ice in clouds, and specifically also on secondary ice formation. They also indicated that the interaction between cloud microphysics and dynamics needs further study. The diurnal cycle of convection, the merging of storm cells, we need to understand those things better. The same with ambient background aerosols, and the analysis of historic data, where we get back to this data sharing and data archiving and data discovery issue. The second main topic was about instrumentation. The accurate measurement of precipitation on the ground over catchment scales is still a problem and needs further attention. Measurement of snowfall, hardened software systems for accurate and consistent measurement of cloud and meteorological variables. We still need a lot of work to do there. Then in terms of seeding itself, the new types of seeding agents, we heard earlier this afternoon of the process when you develop something new. It's not an easy path to follow, and it's a stepwise process and quite hard work and a lot of sweat. To determine exactly what the optimum altitude of seeding is something that's still not very clear. The scaling up seeding of mixed-phased convective clouds. Then the next one was about the issue of modeling, the treatment of condensation nuclei and ice-forming particles in models, the spatial temporal development of clouds, the treatment of seeding material in clouds, finer resolution, model intercomparisons, microphysics and the boundary layer, the dispersion of droplet distributions near the cloud base. And then finally, there was highlighted that issues related to the environment is also important. So we need to look more carefully at extra area effects of seeding. Always keep in mind the possible toxicity of seeding agents. Address the issue of redistribution of surface precipitation, and then look at the whole list of possible environmental risks that could follow from such interventions. So in short, this is what the report highlighted.
Very good. That's great guidance as we develop the roadmap. Very, very thorough analysis of what progress we have now. We have about 5 minutes and we have a couple more questions. I think we can squeeze them in here. Professor Siems, you're the current co-chair of the WMO's expert team on weather modification. and you were also a reviewer of this report. So what are your insights about its outcomes? How often do you think such a report needs to be developed for the rain, for doing the roadmap for rain enhancement?
Well, I guess one of the insights, I guess, that I see from this report is just many aspects of the science ahead of us are not unique to cloud seeding. I mean, we've seen tremendous research on clouds and aerosols from climate perspective. Cloud aerosol interaction is one of the major topics when we go around to different meteorological conferences around the world. So looking at mixed phase clouds, looking at the interaction between the microphysics and the dynamics, looking at the development of convective clouds, these are challenges that are beyond just cloud seeding. So in that sense, I think there's a lot of wealth and a lot of potential to make advances in these fields. We have resources all around the world being invested in these challenges. Specifically getting into precipitation, precipitation on the ground, again, from the hydrology point of view, these are major challenges also to drive the hydrology models. So what's unique to us, though, is this beginning to end perspective of putting in the agent to seeing the precipitation on the ground. How often should we do this? Well, if you had asked me a few years ago, I would have just said 20 years because that's a nice round number. You know, I like it, 20 years. But I mean, advances are coming much, much more quickly now. I don't know, maybe in another 10 years, we'll be ready for another one. But that was a lot of work in that last report. I think it needs to stand for a while. Thank you.
These could be decadal surveys.
Yep.
And you know, rain enhancement is supremely multidisciplinary. So that's another aspect that makes this a grand challenge. Omar, maybe you can tell us about the role NCM has played in commissioning of this report from the WMO, with the WMO to begin with, and then where we're going with it.
Sure, thank you. So NCM has had a long-lasting relationship and partnership with the World Meteorological Organization. And the center plays an active role in representing the United Arab Emirates within the WMO's major forums for global cooperation on the science and understanding of meteorology. In 2017, NCM granted financial support and also sent a representative to attend the meetings of the World Meteorological Organization expert team on weather modification in Geneva. And the report, or the WMO report on rain enhancement, focused on the two cloud types most seeded in the past. So in winter, orographic cloud systems and convective cloud systems, and discussed different seeding techniques and requirements for the design, for implementation and evaluation of catchment scale precipitation enhancement campaigns. Also, the peer review report that was produced was used to guide the collections of scientists and experts who met in January 2020 to determine the targeted research areas for the fourth cycle of the United Arab Emirates Rain Enhancement Program for Rain Enhancement Science. So thank you.
Thank you, Omar. I think we're at the end of our time. I just wanted to thank all the panelists. I think you've shed a tremendous amount of light on what's been done in rain enhancement and how we're going to do the roadmap, the elements that are going to make up the roadmap, and the material like the WMO report that we have to work with. So thank you very much. Have a good day.
Thank you.
Thank you.
Thank you.